This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI podcast. My name is Peter Seeberg and I'm your host. Today I'm going to be talking to Thomas Dhollander, co-founder and CPO. I see that stands for Chief Product Officer. If not, you need to correct me there, at Timeseer.AI. And Thomas and I are going to be talking about trusted IIoT data as the key to proactive operations. Hi, Thomas.
Hi, Peter. Thanks for having me.
Oh, you're welcome. Thomas, why don't you start with introducing yourself to our listeners, please?
Yes, let me give a short introduction. So I'm from a background, I'm an engineer by education, with a bit of a mixed background there in automation on one hand, and on the other hand in machine learning and AI, which already existed back in the 2000s, yet in a slightly different shape than today. Most of the relevant background is with Trendminer and Timeseer, two companies in the industrial AI context, basically. Trendminer was a company I co-founded about 15 years ago now in what we called self-service analytics in manufacturing. So that's very much an analytics focus, working with OT data and process manufacturing primarily. And then after Trendminer, we kind of started a new venture called Timeseer, because we noticed while dealing with analytics work that in industry, that many of the analytics projects didn't really scale well because of data management issues, data quality, data validation problems that were there. And that triggered us to start a new venture called Timeseer, which is what we will be talking about today, I guess.
Exactly. That's what we're going to be concentrating on today. And I do recall that when I was still working at Softing, and that must have been now over, 10 years ago. As you say, you started Trendminer 15 years ago, but sometime there around, I did visit you at some point in time. Yeah. And here we are, 10 or more years later. Don't actually recall, ran into you, probably social media, I guess. And here we are recording and learning from you all about data, all about high quality data. Let's start with a quote that I saw from Andrew Wang on your website, which says, "We don't need better models, we need better data." So what role does Andrew's quote play for you and your company, Timeseer.AI?
I think it's a good conversation starter to start talking about how we didn't care about data management enough in the past and how it becomes a lot more important these days. A lot of emphasis has gone into modeling. When you talk about predictive maintenance or other use cases, people immediately think about models and how to do the best modeling and the fanciest models. But at some point, if you want to scale these things beyond the pilot, in which most pilots are quite successful, many companies struggle with scaling things afterwards, then the handling the data at scale in terms of structuring, contextualization, but certainly also in terms of data validation is something that is increasingly a bottleneck for companies. And there are a number of reasons why the urgency of that topic has been increasing, I think. One of them is, obviously companies started to explore initiatives such as digital twins and others that help them to model things, simulate scenarios, optimize their business. But there are also regulations, energy management initiatives, and reporting that needs to happen at a larger scale. There are verticals in which sensors are being rolled out massively these days. If you think about smart meters, for instance, in utilities, that's more an IoT native use case. There are millions of those meters being installed. The management of that data is becoming a real issue. It's also a big opportunity, of course. It's not just a problem. The data itself is an opportunity by itself. Lots of vendors transitioning to as-a-service business models. If you want to do that, you need to understand how your assets in the field behave at a scale that makes it difficult to do this manually. So you need proper ways of doing that automated. Data sharing is another topic that also triggers the need basically for better data management, better data validation, because you will have certain expectations if you have data sharing happening between companies, certain expectations as to what that data should live up to, especially in the as-a-service economy, of course, where Maybe you have even a contract or an SLA around how the data should behave. So all those things make that dealing with data better, dealing with the data management piece better than before, and in a more structural way becomes more important.
Very good. We probably have been talking for maybe at least a year. I don't know. Gen AI agents, I'm guilty of for the last couple of months. And I'm sure that's all going to continue and all the other great things. And as you say, in the 2000s, machine learning, the good old fashioned AI, maybe even before that, all those things were going to continue to talk about. But I'm really looking forward to talk with you about, how we can make sure that all these great things that we want to do are actually going to be working. And I assume that that's what you're going to be telling us, are going to be working in a more proactive, in a more effective way if we take care of our data. So why don't you give us a couple of examples of the problems that can, and that I'm sure you have seen, we can run into with data on the shop floor?
Sure. And maybe let me take this even a little bit broader than just the shop floor, because there is also use cases in more the IoT side of things, but they're very comparable in a sense. Sensors are not always reliable. Let me start there. People sometimes think if they deal with sensor data that the data is going to be perfect, and that's not the case. You have sensors going stale, for instance, not updating for a long while. We've seen level shifts in sensor measurements because sensors have been replaced and units were mismatched, for instance. You have sensors drifting, calibration being a problem. You have things like meters going offline, and then when they come back online, they give a spike in values because they're somehow compensating for the period in which they were offline. You have obviously also problems in the metadata side. Metadata is often not good in manufacturing, in particular. Metadata of units, of measurements or limits are often wrong, which is not necessarily a big problem on the factory floor itself, because people will usually know that. But as you start using that data outside of the immediate operational context of the factory, that data is very undiscoverable if the metadata is not good. You have compression issues happening with data, correlations being broken, counters counting backwards, glitches in measurements, bringing compressors down. We've seen lots of different issues, and they have a varying impact, of course, on operations. It's not just the impact on operations, by the way. So, like I told you before, it's when you start lifting that data out of its direct operational context, and you start doing these initiatives on a larger scale, like these overarching digital twin models, or when you start to build AI models also on a central level. Those issues are even more pronounced, because on the factory floor, sometimes people have some workarounds to cover some of this already. But as you lift the data up into the clouds, typically also, then it becomes worse sometimes.
Okay, yeah. Sounds also like maybe the further people are away from the actual data, maybe the less they know, as you say. Maybe sometimes people on let's say, as an example, the shop floor know about certain problems and they go around him, even if they look at the data. Oh, that's okay because we know exactly what it is. But if the same data is still being used further away somewhere, maybe at the other side of the world, I don't know. Maybe people do not know that, right?
Well, even on the shop floor, you would sometimes be surprised, right? We sometimes see that E&I, for instance, knows very well that a certain sensor is unreliable because it has been mounted incorrectly, but people on the shop floor itself don't have a structural way of knowing that. It's just word of mouth, basically. And then sometimes they know, sometimes they don't, I guess.
Okay, so now we're going to be talking, about, your solution. Maybe you can give us an idea on, before we then go into the details of what your solution is, of exactly what is going to be that difference. It's almost like listening to you, and I can confirm from own experience some of the problems that occur, but hearing the vast potential of things that can happen, it's almost impossible to understand how we can still do some analytics on data. So what is let's say, your approach and getting into the details in between you providing a service on the quality of the data? So if it's there or if it's not there, what it is that you're going to be doing?
Yeah, maybe let me start by breaking this down a little bit in terms of what kind of problems we can help with from a business side of things, because we talked about the sensor issues and so on, but there's basically three buckets of things we can help with. On one hand, in certain use cases, people are working with the data we're talking about, the sensor data, manually. You have data scientists doing manual data prep, but in some verticals, you have people doing manual data validation for data that's used in billing, for instance. We can drastically help to speed that up. So that's one area. The second area is where you have digitalization teams or teams that are responsible for one of those high level data products that I was talking about, be it a digital twin model or be it a predictive maintenance solution on a high level. Those teams often have trouble scaling those initiatives in a robust way. So that is the second thing we can help with. And the third thing we can help with is more on the operations and service stakeholders, if you want to call them that way, to basically allow them to monitor SLAs, for instance, between OT and IT, or to help them to see if machine states start deviating from standards, make sure their environmental reports or their energy reports, their OEE reports are correct. So that's the three buckets: the people working manually with data, typically data analysts, data scientists, digitalization teams, and then the operations and service stakeholders. And to do that, we have a number of things, capabilities basically that we have developed. Do you want me to go into those or?
Please do. That's exactly what I would like to know. So you have a solution. Maybe you tell us what that solution is, and yes, as you say, what it can do. What are the components of that solution?
Yeah. So the core things we do is we typically connect to places where IoT or OT data ends up. Being a bit vague on it, because there are so many places where IoT and OT sensor data ends up these days. It's the classical automation landscape, maybe a data historian on a factory floor or on in a cloud-based version of that. But it's also, and increasingly, platforms like Databricks or an S3 in AWS or an Azure Data Fabric or Data Explorer. So it's an increasing number of places where data is being handled that we deal with, and we connect to all of these. Also, of course, the typical time series databases like Influx and others. So we have good infrastructure to do that, to then map onto a data model that is a time series, asset, and metadata model in a flexible way. So we are able to tap data from one place, metadata from another place, to merge things together, to basically map onto a solid data model that also works across the boundaries of typical IoT and OT landscape, and that is good out of the box for IoT data. And that is a difference from, let's say, many horizontal solutions to data management. We know how IoT data and OT data works. We know what an asset structure is and how you should deal with that, templates and those things. So connectivity, data model, and then we go into setting up pipelines, typically at scale, for detecting, finding issues or features, events of interest in data. So we have built up infrastructure that is capable of handling millions of sensors without a problem in that sense, that knows how to do this incrementally as well as in batch fashion. And that has a number of algorithms out of the box for typical sensor issues, and increasingly also for certain use cases that require specific events to be detected. And it's not just detecting them. These pipelines are also capable of doing cleaning steps and so on. And it's extendable concept. You can plug in your own algorithms for detection and cleaning and so on. And then the third component is really about the scoring and summarization part, where we take all of these things we find and we help you to get insights into the results. Now, it's not just displaying the results, because you might find very many results in that data, and you don't want to have this huge list of things to go through. So we summarize things into data quality incidents or data incidents. We provide you insights we think are relevant given the use case you're doing or the sensors you're working with. And obviously, we're also using some AI for that. Also on the detection part, we're using time series AI on the detection part. We're using language model AI also on the summarization part, as well as on the interpretation and the copilot for suggesting which checks to use. So there's different pieces of AI in there. Now, the scoring and summarization is one thing. Then, of course, you want to solve the problems, right? So suppose you have these incidents surfacing that tell you have many duplicate timestamps in your data or whatever it is. We want you to help to be able to solve those issues as well. And there's different things we help with there. We have a way of doing low-code data validation flows where people manually validate data, go through results, do triage, solve them. But you can also add your fixes in certain cases to these pipelines that I was talking about before to do them automated at scale in the future. And so you have these two components. Maybe let me keep it at that for now.
Yeah. Sounds great. Following here, so and what I'm thinking of then is like, certain problems can be solved, if I understand it correctly, algorithmically. So you do that on the fly or in your pipeline, but it may also point to a structural, let's say, more mechanical issue, let's say somewhere in the factory or somewhere in an IIoT environment, which then at some point in time an engineer needs to take care of. Is it fair to make that division between those two categories of potential problems, ones that you can immediately solve and other ones that need to be taken care of? Or
Yes, you cannot solve everything immediately, and you cannot solve everything by just applying cleaning steps or fixes to the data. And so oftentimes the fixes you do to the data are more the temporary fix, and then the actual fix needs to happen in the physical world or by changing a configuration or improving a pipeline somehow. But it's really the combination of both, right? Sometimes the result needs to, certain results need to go back to people more on the operational side. Other results need to go back more to people on that manage data pipelines, for instance. So that's where the concept of data stewardship data stewardship and data management comes into play. And we have a component. So next to the pipeline infrastructure, we have the second component that is really suited for data stewardship, data analyst and data stewardship. But anyway, a business user dealing with the results and deciding what to do with them.
okay, let's stay with the user here. You just already kind of mentioned two here. So who are your target audience users typically in your customers' organizations that would be using your solution?
So on one hand, that's what I was saying before. On one hand, you have these roles that manually work with data. Of course, a data scientist is a completely different role than a data analyst. So if we have a data scientist dealing with our software, he would often, or he or she would often deal with it from our Python SDK and then tap into results that we've been finding to get contextualized, quality contextualized, often data in a Python environment for modeling, or select periods of data that are reliable to use in the models. You have data analysts that are often indeed in charge of sometimes manual validation steps to commit that the data that they're looking at is fit for use, or that they're responsible for rather is fit for use. A use case in that respect is billing and utilities. If you have utilities companies, water companies, for instance, they send out bills to customers for critical bills and, let's say, industrial size consumption. There's people actually responsible for looking at the data and making sure that it's good. And so that's where those people interact with the platform. If you look more at those digitalization teams, like I was talking about before, digital twin team, for instance, responsible for managing the digital twin data product, then they will be more in charge of at-scale pipelines to deal with the data that feeds into those twins to make sure that is reliable. They might deal with the UI, and they probably often do, but they also have other ways of doing this at scale, like config by code, Power BI integrations, and so on, that they can use to integrate what we find into their landscape. And by the way, they also sometimes tap into cleaned data and use that cleaned data for their data product. So that is another way of interacting with Timeseer. And they don't necessarily need to be in Timeseer for that, but Timeseer will expose clean data, and they use that clean data in their data product. And then you have these third category of these operations and service stakeholders, where basically what they want to know is when there is reasons to believe the data they use in their reports or the data they get from their service provider is not reliable, then they want to be in the know of that, or they want to know that. So that's where we can help them, and that's either via the UI, via notifications, and so on. It's a combination of that.
Now, in how far does actually your solution, as part of many other solutions around AI, facilitate, let's say, in general, domain experts? We have called them in the past citizen data scientists, but I want to go even further than that. They don't need to be a data scientist. If I look back, and at the same time, that I have been myself involved, and I, as a person, not having been, a studied data scientist, I would not be able to have been to take care of problems that we just talked about. Now, if I have a solution like yours and I am the responsible domain expert, whatever my specific role is in the factory, in regards to utilities, etc., does that then your solution plus others empower me to say, now I can take care of it myself, and only every now and then I will need the help of a more specialized data scientist person?
Yes, it can certainly help you in two ways, I think. I mean, one is it can help you be more effective in that job. I say if you're the responsible business persona, basically responsible for a certain data product, whatever it is in the landscape, then Timeseer can greatly help you in taking your steward role in an efficient way. People are often struggling with those new role titles in data governance, like data stewardship. What does it mean? What does it mean for me as a person in terms of time spent and so on? We can help to make that really accessible and also really efficient, to only go through issues that are likely requiring your attention, not sifting through data endlessly as a data steward. Get alerts when you need to attend to something instead of having to somehow figure that out manually. So that is certainly something we can help with.
So data steward, is that a new role? I mean, it's a term that I have not necessarily heard before. You want to explain what that role is?
In data governance, that is the role that is typically responsible for making sure that the data is living up to the standards you expect from it. It's the business persona, so it's not a really technical role. It's the business persona that takes that responsibility. People sometimes think it's a new hire. Typically, it's not. Typically, it's a business persona you already have and that already exists in your landscape, but that takes an extra responsibility for a certain use case. Typically, say if you're going back to the digital twin, someone that guarantees or helps to guarantee that the digital twin data is reliable.
Okay, so that it's almost like an example of what I call the domain expert, so to say. And my question would almost go one step further, specifically as you shared with me, your solution is not just for the shop floor. That's what we typically take care, but you are about utilities as well. And I living in a country where digitalization has not necessarily been number one, but who knows, we're going to get there at some point in time. These days, I have the opportunity to go down in my cellar with regards to what is it, electricity, I guess, right? So the electricity bill. So I can make, I think, a photograph. And the last time I did it, even it went through WhatsApp, I believe. So, and I'm not sure if that is connected to your solution, so to say. But that means that a consumer is providing data in a new way, not by writing down 1, 2, 3, 4, 5, but using technology, and whatever that number is going to be then at the utilities provider, they want to give me the right bill. Is that let's say a use case where even consumers are related to maybe even come into your solution as well?
To a certain extent, it's something that the companies that we work with are dealing with. Like the use case you were sketching is one that we definitely have seen in water utilities, for instance. Also, companies, by the way, providing solutions like cameras you can actually put on meters to because the meters are not retrofittable to have direct connectivity to basically go via the image of the counter, send that data that way. So it's a mix between let's say really online devices, some intermediate solutions to retrofit old devices, and then indeed also some consumer based input, and to check the consistency of all that data and pick up the anomalies that are relevant for responsibles at the utilities companies or at the metering companies to look at is a challenge at the scale we're starting to see this, which is many millions of meters, for instance. Yeah.
Yeah, which is what we want, right? We want things to become more digital. Now, you talked about places. You put it very nicely. You talk about, Historian, Databricks, any of the cloud providers. So that's going to be my next question. Is that where your solution sits? Typically, some kind of cloud solution. Can it be edge solution? And what does that mean for the integration with other, if there's another already available, maybe industrial general AI solution data stack?
Yeah, the interesting challenge is that we started building a product that we never claimed is kind of an endpoint in a landscape. It's not neither the start point nor the endpoint. So we're not a platform where you put data. We are playing with whatever data infrastructure a customer has. And that data infrastructure can be a variety of things, like I said before. But that also means in terms of deployment, you don't want to be running massive checks on data in as a SaaS solution that requires pulling all the data out of whatever on-prem or cloud solution the customer has. That is not a very efficient and economically friendly way of doing business. So what we do is the data scanning typically happens where the data resides or where the data enter some kind of hub, because we can also connect to things like Kinesis or other endpoints like that. So the scanning piece, the pipeline piece I was talking about, typically runs close to the where the data is available. We don't require it to travel to a SaaS piece on our end. And in fact, many customers deploy the whole Timeseer solution in their cloud subscription, for instance, if they're dealing with AWS or Azure, and have also the steward layer or the interactive layer, the result summarization layer deployed there. But we are very flexible in deployment. We can even deploy on a Windows as a Windows service. We also can and do hosted environments or SaaS setups as well. And then in terms of connectivity, it's not just connectivity on the incoming side. It's also where do you put the clean data or the output of results we generate, and that also needs to end up back in the customer landscape. It's not just the source connectivity.
Now, I'm not a daily user of the solutions like AWS, Azure, and the other ones. Is there a certain overlap, realistically thinking, of solutions that let's say, not as powerful or not as widely or not as specific? So can you talk about that? So is there the option that each of them give to, clean your data, and a base solution? And if so, how does that work together?
So many of these platforms have some built-in capabilities to do something in terms of data management, of course. I'm putting it broad on purpose. Data management meaning could be structuring data, contextualizing, cleaning, validating. But those solutions only take you a certain distance. We often pick up customers that started to build things themselves on a platform, let's say Databricks. They have their data in Databricks. You can do lots of things in Databricks. It's a building block environment, right? You can do some data quality management or some data validation stuff in Databricks as well. But as you start going from, let's say, rule-based checks to, let's say, more model-based checks you want to do on the data, and you want to do that in an accurate and robust way, and you want to factor in your asset models, and then you want to go into stewardship and manual and validation, and you need an interface for that and a UI for that, and then you want to also do cleaning and stuff like that. It becomes a very big solution that you are in essence building yourself and maintaining, and that's where the total cost of ownership question comes in. We see many companies that have kind of built some lightweight versions and then come to us and say, look, we don't know how to scale this further. It's just not manageable. Because if I talk about scalability, it's not just technical scalability, it's not just performance of running this on millions of sensors, it's also how do you make the configuration of it manageable, and how do you keep that under control. How do you make sure the number of alarms you're getting is under control, and it's not some kind of flooding of alarms you're getting from these systems you're putting in place. So it's all of that.
Okay, we mentioned, or we thought of think about customers. How do they? So, who are your customers? I don't need names. It's like a specific market segments. Well, we say industrial IoT, specific parts of the world, and then moving into where actually you're operating.
Yeah. So to begin with, we do business both with manufacturing companies, directly. We also do business with utilities companies directly, both in water and energy verticals. And then we have a number of parties that are on the IoT side of things typically, that are also have a B2B model of their own in terms of what they do with the data. So you have these intermediate parties, sometimes say in utilities, some areas of the world have rather small utility companies. Then we're also dealing with parties, sometimes it's meter vendors or others, that actually have lots of these utilities already as their customers, and they are offering solutions to those customers, also based on the data they gather. Like they help the utilities figure out whether something is potentially wrong in their network, which might indicate that there are water leakages or things like that. Then we also, those are very good partners for us, or very good customers for us to work with, because they can help us rapidly scale into those markets faster. So in terms of the manufacturing space, if I can go back to that for a moment, it's both. It's mostly process manufacturing, but also some discrete that we're working with, and that ranges from oil and gas over chemicals, some food and bath. It's really a rather wide range at the moment. We also have partners that we work with, and maybe that's good to highlight in the sense that, yeah, we're a product company. We built this product, this platform. We have companies that help us bring that to market, but also help us if there's any aftercare needed or services needed. Companies, I'm a bit afraid to do name dropping, because I might miss a few, and that's always a bit of
As you wish, as you wish.
right. But it's system integrator type of companies. It's companies that help to set up data landscapes in manufacturing environments. And then we also have the big ones like Microsoft, AWS, Aviva, Databricks that we are partnering with.
And they are part of, I see you have some kind of an advisory board as well.
That's right. The advisory board is something that we put in place rather early. It's something that we learned in our journey at TrampMiner can make a big difference in terms of making good strategic calls. We don't know everything, so we've gathered this group of 20, 30, well, really senior people from industry, both from customers of ours, but also from those bigger partners or hyperscalers and others in the landscape that have an interesting additional perspective. Also some sensor vendors, because we're dealing with sensor data a lot. And we've compiled this group. We bring them together 4 times a year to discuss some topics, typically a keynote presentation, some roundtable discussion, and then also some strategic considerations for what Timeseer is or can do in that context.
Very good. Yeah, it reminds me my time at Inter, we were doing something very similar, very useful. So let's come to a close. Thomas, tell us a little bit more about your team. Where are you based? I believe what parts of the world? Who are your colleagues? Are you looking for colleagues? If so, what should they bring?
Okay. We have a fantastic team. We're not that many at the moment. We're about 15 people strong, but we are a fantastic team with the best people I've worked with, both on the technical and the commercial sides in my career so far, and some new ones. We're located, officially, we have our headquarters in Belgium. We have an office in Houston, but we are basically spread out. So we have some people working from Brazil, Germany, and so on. So it's a bit of a, with COVID, a bit of a remote working setup in many cases. We also are interested in the world as our market. So we do business with global companies. We have big customers in the US as well as in Europe. And it's not just Belgium, it's Belgium, Germany, Spain, the Nordics, and so on. Yeah, in terms of colleagues, we're always looking for good colleagues in different areas, customer success side, the technical side. And by the way, I didn't say it when I was talking about partners. But if people are interested to do business with us from that perspective, I'm certainly open to that as well.
Sounds great. Thank you very much, Thomas. I'm going to just close with what I started with, the quote from Andrew Wang. We don't need better models, we need better data. We will continue to talk about models in the future again as well. Gen AI, agents, and all the great stuff. And as I said, we will do that. And knowing that if we have clean data, if we have perfect data that we can get by using your solution, we can do all those wonderful, great things that we want to do even better and even, more efficient, I guess, right?
Absolutely.
Thomas, thank you very much. Have a great day.
Yes, thanks, Peter. Have a good day. Bye-bye.